Okay, next up we're going to take a look at an injector. So say maybe you found a particular anomaly with one of the cylinders and you think, oh, performance is down on one. Let's go in a bit deeper and actually take a better look at what those injectors are doing. Now typically in off-highway they refer to hot and cold side of injectors. The hot being the power supply side and obviously the cold being the ground switched side. Fortunately, there is a lovely, like I said, a breakout lead that will go straight into the head on this particular engine. That means we get perfect access to all of the pins that are available, and we can also get a current clamp easily around the signal wire as well. We have our scope settings as before as the default setup. Obviously, BNC Plus means that we can just straight away plug and play. We've set our ranges to allow for the maximum tolerances that we should maybe expecting to see. So what we're going to do now is get the scope running. We'll get the engine running and then we'll try and fine tune our settings to make sure that we can get that injector profile nicely on the screen. Okay, start her up. Okay, so there is some over-ranging going on. So our plus or minus 50 isn't enough. So let's go one more on each of those. So plus or minus 100 now. And as we can see, we've got our signal so that we're no longer over-ranging. Okay. What we're going to do now is then increase the speed that scope is capturing. So we're going to decrease the time base. We're going to keep going to a point where we can see it moving and jumping across the screen. So 20 milliseconds per division. What we want to do is introduce a trigger now, which is going to help us stabilize that image. So we can go in again and actually get closer and closer to see what's happening. Top toolbar, trigger. We're going to use the auto option. That means if you get the trigger wrong, it will always still capture something. Click on auto. We want it on channel C, because that is the one that's not going to be moving around as the other two are. So as we can see there now at the moment, channel C is going to be moving between them. That means current isn't flowing at one particular point. So we need to make sure we're on the right one. So channel C, current is work done. We can pick up the yellow diamond and we can move it about onto the screen to help stabilize that image. Once we're happy, again, we can keep dropping our time base so we can see exactly what is going on with that signal. We're going to stop there and we're going to switch it off. Okay, so we have our capture. We can now go in and we can see the exact detail that's happening within that injector itself. So we can see we're hitting the injector 3 times. This can vary between different engines as well. So sometimes it's possible to see 2, sometimes there will be 5. It all very much depends on how the system has been set up. We can zoom in further to each individual pattern. So now we can see we have a PWM controlled signal side, and that's obviously going to reduce the current, so we can do current limiting. We have our main signal as the peak inrush, so that's obviously going to get the injector needle moving. Once it's up and running, obviously the current then drops due to the PWM signal, and then obviously as everything collapses, we have our inductive kick afterwards. So I have that capture now, so well, what good's that? Well, if you're happy with that particular capture and it looks okay, or even if it doesn't, we can now make a very simple reference waveform of each of those signals if we want, and then compare it to the next cylinder. Again, breakout leads make this a lot easier. So what we'll do is we will make a reference, but first I'm actually going to introduce a new viewport. That will allow me to keep my known good on top of what's actually going to be coming in underneath. So we click Views, we're going to add a scope view, and if we just separate these ones out here, now in the top view, this is where I want to keep my references. So I'm going to click on Reference Waveforms. I want to make a reference of channel A, B, and C. You'll see in this top viewport actually now we have some extra axes that have appeared. Now I'm not interested in seeing what channel A's and B and C is going to be in this top viewport, because ultimately they're going to be different because they're going to be connected to the machine. So what I need to do is turn off those ones in the top viewport. So now we can see they're slightly fainter, slightly different colour. Now if I was to run the scope now, we should see that the bottom one, remember it's an auto trigger, so even though the trigger's not met, it's still going to start recording something, has gone to flat lines. Of course it has, the machine's not running. The top viewport still has our known good, or our reference waveform that we're going to compare to the next cylinder. So, fingers crossed, because now this is the point where you're going to try and make connections and we're just going to hope we're on the right wires. So we're just going to shift our voltage leads to the other wires that are there on the breakout lead. Going to attach our current clamp. Again, we have a 50-50 chance of getting it right. Or sorry, getting it the right way up so that the signal's around the right way. And we're going to start the vehicle, start the machine. So as luck would have it, they are right. So now we actually have a different injector now. So this will be, as I said before, this machine, there's 2 injectors per that in that particular harness. So that means I was in injector 3 before, and now I'm on injector 4 now. So we turn that, we'll stop the scope and we'll switch the engine off. Okay, so how's that particularly useful? Well, now I have all the controls for both sides, or for both of the reference waveform, and similar time-based controls for the new captured one. So now we can actually see how much of a difference there is between these 2 injectors. So to start off with, I've just made a very, very sort of rough line-up of how the signal for the first sort of strike of the injector. So in our top viewport, so this was our previous injector, remember, this is our reference, we have a time period of on time for 318 microseconds. In the one underneath, we have 306, so it's slightly different. So hopefully this is a quick way of showing how you can use reference waveforms to quickly analyze the vehicle and the machine. Different systems, different components, injectors are a prime example here. Getting the references, making the measurements, and then comparing them relatively to each other. It's a nice little tip with the viewports, and obviously in PicoScope 7 we can manipulate these much more easier than what we could in PicoScope 6. So I hope that helps, and we'll start looking at the next test.